Here we have an inequality, a compound inequality, where we're solving 7n plus 1 is greater than or equal to negative 2n minus 8, or 4n minus 9 is greater than or equal to 7n plus 3. So I just highlighted those two inequalities so that we can see them, because before they're highlighted, it looks like all of it just ends up being one great big inequality. But the word or separates the two inequalities, creating that compound inequality. So we'll solve 7n plus 1 is greater than or equal to negative 2n minus 8. We'll solve that one first. I'm going to add the 2n to both sides, which gives me 9n plus 1 is greater than or equal to negative 8. I'm going to subtract the 1 from both sides, and I get 9n is greater than or equal to negative 9. Now I'm going to divide both sides by positive 9. 9n is greater than or equal to negative 1. Now I can solve the second inequality. 4n minus 9 is greater than or equal to 7n plus 3. I'm going to subtract the 7n, giving me negative 3n. I'm going to add the 9 to both sides, which gives me negative 3n is greater than or equal to 12. Now I divide both sides by negative 3. And when I divide an inequality by a negative, I have to flip the inequality symbol. So I have n is less than or equal to negative 4. This is my solution as an inequality. So this is the inequality solution right here. However, I want to graph that solution. So I'm going to come up above. N is greater than or equal to negative 1. That's a closed interval, so I have a bracket. Greater than or equal to negative 1. And then the other solution is n is less than or equal to negative 4. That is also a closed interval. This is my graphing solution. So I'm going to write that graphing solution. However, many times we want the interval solution. So we want the solution in interval notation. So from the graph, it's pretty easy to determine that interval. You've got negative infinity to negative 4. And then you have negative 1, and that's a bracket at negative 4. And then we have negative 1 to infinity, to positive infinity. Like that. So I'm going to come off over here, and I'm going to write that as negative infinity, comma, negative 4 with a bracket, and then union with another bracket, negative 1 to infinity. And this is our interval notation. And this is probably the most popular way of writing your answer. It's an interval notation. So let's try another one of those. We have 9 plus 6p. I like highlighting these because then I can see the actual inequality a little bit clearer. 9 plus 6p is greater than 7p plus 3. And 6p minus 6 is greater than 5p plus 7. So why don't we have you try this? I would press pause and give it a whirl, and if you get stuck, you can always press play and check out how I'm doing the problem. If you don't get stuck, then that's wonderful. Then you can just press play to check your answer. So I'm going to go through this rather quickly. I have 9 plus 6p is greater than 7p plus 3. I'm going to subtract the 7p, I'm going to subtract the 9. Then I'm going to divide both sides by -1, and I get p is less than 6. Or 6p minus 6 is greater than 5p plus 7. Subtract the 5p, add the 6, and I get or p is greater than 13. So p is less than 6 is an open interval shading to the left towards negative infinity, and p is greater than 13 is an open interval shaded towards the right towards positive infinity. And our answer in interval notation is negative infinity to 6 with an open interval, union with 13 to infinity, both open intervals.